As we start Lab 2, I wanted to give you a quick overview of what you learned in Lab 1 and run through what you need to know for the next lab. So in Lab 1, we learned the workflow. So we went through that. We're going to review that in a second. But the point was that we only had one line of code to fix for each of the two projects that we did. We ran through the full workload on that. In this next lab, we're going to only have one project, but there's going to be 3 modules to write and some things to instantiate, 4 things to instantiate. So we'll go through it. Let's review. So in Lab 1, the workflow that we did was you accepted an assignment, you cloned it, all right? So accepting an assignment generated a repo up in GitHub. It was the private repo that exists between the two of us, between the student and the instructor. Okay, then you clone this to your box drive. So now it's in a local space that you can have access to on the computer. So we accept the assignment, we clone it. Then you go to Vivado and you create the project and you add all the source files. So that would be the design files, the test bench files, the constraint files. From there, you can look at how things work in Vivado. We're not going to concentrate on that a lot today in the lab. That's going to be the focus of next week. But I do want you to run the simulations and look at the Tickle console, make sure that it passes the tests and so forth. Then we go through the workflow where you synthesize and implement and the process of generating a bit stream. There might have been a step missing here in that workflow. And then you program the FPGA and you see your design working. So that's what we did in Lab 1. And so it's basically the same ideas in Lab 2, but we're going to add some new things. You're going to write your own modules. You're going to start looking at how to learn actually Vivado. Okay, so we're going to write some modules. You're still going to test each module like we did before, but this time the test is more meaningful because you had to do more work to make that happen. And along the way, you had to instantiate things like you did in the pre-lab, so you have skills on doing that, and then you can test the system. Okay, so going to the next step, the modules that we have. So this is a toy problem. It's not a practical thing. It's just showing how you can put together some modules in Verilog. And so I wanted to make them easy modules, so each one is just a logic function. Okay, so the logic function is given. This one says majority of inputs, but if you look through the documentation on the lab, it actually gives you the logic function. So logic function 0, logic function 1, logic function 2, logic function 4. There's a pattern that you have here. You're going to have to go through and define the ports. This is a module that gives you the template to look at, and you duplicate that idea and learn about the process, make the ports, assign any wires that you might need to do. I don't think you need wires in this case, but then write the function and make sure that the ports match the documentation. So I've included an RTL diagram that has inputs and outputs labeled. So you need to make that match and get it exactly right. So you write all these, you now have 4 logic functions, and you've instantiated those within the Vivado files. So you did those 4 things, and then you have to put it into the top, the thing where we integrate all the logic functions together. You're editing this file where you instantiate those things in, and then there's a wrapper that connects your design to the actual support circuitry that lets the display happen. So don't worry too much if you don't understand all what's happening in the wrapper, but you do need to instantiate this logic functions top that you created by putting together 4 other logic functions. So hopefully you see the pattern here. You're building stuff up and then you wrap it into another module. So now there's this hierarchical design where these 4 things are in this thing, and then this thing gets put into the top thing that wraps it up and puts it to the hardware. Okay, so we'll have the same workflow as before. You're going to go to hit a link, accept the assignment, clone the repo. Okay, you're going to study the first logic function, then you're going to write the next the next 3 logic functions. So you have 4 in all. All right, and then you're going to instantiate everything well, you can load these into Vivado to make these edits. You actually have a choice here. You could make the edits up in GitHub like we did with the pre-labs, but you can make the edits also in Vivado. You're going to test each module, make sure everything's instantiated correctly, test the overall system in Vivado looking at the test benches. Then you're going to go through the workflow and program and test the device. Okay, at the end, you're going to have a table. So you have switches that you'll control, and you're going to put these input combinations. Each of these is 4 variable logic functions that we've all tied together with a common input. These are the truth tables for that. You can verify those yourself. And then we took the outputs of each of the logic functions and put it to the hex display. So it's easy to verify if your circuit is working. You put in all zeros, you should get 8. You put 0, 0, 1, you should get A. So I'm going to want you to verify the circuit working and make sure that you can show that in hardware. All right, so that's the basics of Lab 2.